Lesson 11:6, Adding and Subtracting Rational Expressions. In this video, we will learn to add and subtract rational expressions with like denominators and add and subtract rational expressions with unlike denominators. Vocabulary is least common multiple and least common denominator. Okay, so if you guys remember from adding and subtracting fractions, if you have the same denominator, you leave the denominator and you add the numerators. So a over c plus b over c is a plus b over c. And same thing with subtraction. So it would be a minus b over c if you had a over c minus b over c. So it's the same with rational expressions. So if we have variables in there, it's going to be the same idea. So we already have the common denominator, so that's going to stay the same. And then I add my numerator. So 4b plus 16b. So 4b plus 16b makes a total of 20b over 15. Sorry. And then what we want to do is simplify this. So 20 over 15 does reduce. They're both divisible by 5. So I'm going to get 4b over 3 if I divide numerator and denominator by 5. And that would be your answer. Okay, you guys try this. Okay, if we want to subtract rational expressions with like denominators, again, the denominator, because it's already the same for both, we're just going to leave it. So it's going to be x minus 3. But the numerators, we're going to subtract those. So it's 7x plus 9 minus this whole thing. So I have to put that in parentheses. So now when I go to simplify this, I'm going to have 7x plus 9. Distributing this negative, it's going to be minus x plus 5 over x minus 3. And now I just want to combine like terms in the numerator. So 7x and negative x makes a total of 6x, and 9 and 5 makes 14 over x minus 3. And that's as much as we can do with this one. Okay, here, what happens if on the bottom here again we have x minus 11 minus x, and this one's x minus 11. So they're not quite the same. So if I want to make them the same, using the same idea that we used in previous sections, we can say that this is going to be the same thing as negative 11 minus x. So if I want to switch them, I just put a negative out front. Okay, so what I could do is I can cancel those negatives, and I can say this is 3x over 11 minus x plus 5x over 11 minus x. And now I can add those. So I'm going to have 11 minus x over, well, 8x over that. And then that's as much as we can do. Okay. We need to be able to find the least common multiple in order to find the least common denominators later. So far, all of the rational expressions that we've had have had a common denominator. So we need to look at them when they don't. And in order to do that, we need to be able to look at things like this and figure out when they have least common multiples. So what I like to do is break it up. So the numbers 12, I can say that the same thing as 6 times 2, but then 6 can break up further, and you can say that's 2 times 3. Okay, and then looking at 32, the first number that pops in my head is 8 and 4, but then we can break these up. I can say 2 and 4, and then 4 breaks up 2 and 2, and this one also breaks up 2 and 2. So what we're going to do, we have to account for everything in this list. So from this list, I need at least 2 2's and a 3. From this one, I already counted for 2 2's. Okay, so that means I need to add 3 more 2's. So 2 times 2 times 2. So when I multiply all these together, that's going to be the least common multiple of my the numbers 32 and 12. So when I do this, I get 96. So my least common multiple is going to be 96. Okay, and then for the variables, b to the fourth and b, it's always going to be the highest power. So this is going to be b to the fourth. And for c's, I have c to the fifth and c squared. So the highest power is c to the fifth. Okay, so this is my least common multiple. Okay, if I want to find the least common multiple of something like quadratics, what I want to do is factor it as much as I can. So doing a factor tree like I did before. So first I want to do is break this up and to see what two things multiply together to get this. Well, that's going to be those two things as if it was factored. Something, okay, what multiplies to 28 and adds to negative 3? So 7 times 4 is 28, and the difference of those is 3. So I'm going to have x minus 7 because I want it to be the bigger number to be negative, so that I get negative 3, and x plus 4. Okay, and then I want to go and multiply this together too. So, or figure out, factor this. So, I want to multiply 7 and add to negative 8, so it's going to be x minus 7 and x minus 1. Okay, so now in my least common multiple, everything in my factor trees has to be accounted for. So in this one, I need x minus 7 and x plus 4. Here, I already have x minus 7 accounted for, so I don't need to write it again. But I need to add the x minus 1. So this is my least common multiple, those three factors multiplied together. Okay, so you guys do these ones. Okay, so if I want to add or subtract rational expressions with unlike denominators, first I need to find the least common denominator, which is going to come from the least common multiple. Write each rational expression as an equivalent expression with the least common denominator as the denominator, and then add or subtract the numerators and write the result over the common denominator. Simplify if possible. So let's do one. So first step, I need to find the least common denominator between my denominators. So in order to do that, I need to factor this part here. So if I were to factor that, I'm going to get x, and I want to multiply to 9 and add to negative 6. So it's going to be minus 3 and minus 3. Now, the least common multiple, or in our case, the least common denominator, has to have everything accounted for. So from this one, I need to have x minus 3 and x minus 3. Now, if I go to this one, it's already on my list, so I can just leave it at that. So my least common multiple, or denominator, is going to be x minus 3 squared, or x minus 3. So this one already has that. So I'm just going to write this as x plus 7 over x minus 3 times x minus 3. Okay, and then this one here, I have x plus 3 over x minus 3. So in order to get this the same, I need one more x minus 3 here. So if I do x minus 3 to the bottom, I also have to do it to the top. So now I have this. So now that I have a common denominator, I can add my numerators and say this is x plus 7 plus x minus 3 times x minus 3. And all of that is over x minus 3 times x minus 3. And we just want to check and make sure that this doesn't simplify at all. So what we have to do is simplify the numerator up here. So this is going to be x plus 7 plus this thing here. If I were to FOIL this back out, I get back to this. So it's going to be x squared minus 6x plus 9 over x minus 3. And we'll just say squared for now. So I need to combine like terms here. So this is going to become x squared minus 5x plus 16 over x minus 3 squared. And I want to see if this thing factors so that it cancels with one of these. So I'm trying to think of anything that multiplies to 16 and adds to -5. 8 and 2 doesn't work. 4 and 4 doesn't work. 16 and 1 doesn't work. 2 and 8 doesn't work. So nothing factors. This does not factor. So this is simplified as it goes. And we stop there. So you guys do this one. Okay, example 6. For the first 15 miles, a biker travels at X miles per hour. Then, due to downhill slope, the biker travels 2 miles at a speed that is 2 times as fast. Write an expression to represent how much time the biker is biking. So for this one, if we want to write an expression to figure out how much time the biker is bicycling, we need to find an equation for time. So we know that distance over time is rate, right? Because like miles per hour is the distance and time. So if I want to find an equation for time, I can rearrange this equation and say that time is equal to the rate over the distance. So if I want to find a total equation for time for both parts, for the first part, it's 15 miles at X miles per hour. So 15 over X is going to be the first part. And then it says he travels 2 miles at a speed, so my rate now is twice as fast. So we have miles on top, sorry, I mixed this up. It's time equals distance over the rate. So we have the miles on top and the rate on the bottom. So if I wanted to do this, I need to combine these. I need to find a common denominator. So this one is 2 times x, and this one's just x. So in order to get this the same, I need to multiply it by 2. So whatever I do to the bottom, I have to do to the top. So this is going to be equal to 30 over 2x plus 2 over 2x. So I can say this is 32 over 2x, and that would be 16 over x if I simplified that. So the time that this biker traveled is equal to 16 divided by the rate he was going in his first 15 minutes. So for part B, it says find if the biker is bicycling at a rate of 8 miles per hour for the first 15 miles, find the total amount of time the biker is biking. So we just said that our time is equal to 16 divided by our x, or our rate. So we're putting in 8 miles per hour. So we're putting in 8 there. 16 divided by 8 is 2, and that's time, and we're measuring in miles per hour, so that's 2 hours. Okay. You guys try. Okay, last one is subtract rational expressions with unlike denominators. So again, we want to get a common denominator. So this is 8 times x, and here we just have x. So I need to multiply top and bottom of that first equation by 8 to get them to be the same. Sorry, minus 5x minus 2 over 8x. So again, this becomes 24 over 8x minus 5x minus 2 over 8x. Now I can rewrite this as all over 8x because I have a common denominator, and I have 24 minus this whole thing again. So remember to put it in parentheses. So this is 24 minus 5x plus 2 over 8x. Combining like terms, I get 26 minus 5x over 8x, and there's nothing I can factor out here. So this is as simplified as it gets. Okay. You guys do this one. And that is the end of lesson 11's